myself Virendra Shashi and studied by the Government Polytechnic Hubli in 5th sem Mechanical. So I will discuss by the today new topic is Hall effect sensor. I'll continue by the slide wise. First one is construction. Definition, explain working, advantages and disadvantages and application. Let us continue by the one by one. One is definition. The current is flowing a conductor can be duplicated by the magnetic field. This effect is known as Hall effect sensor. Next continue by the explain. When a beam is charged, the particular passing through the magnetic field act on the particular and the beam is duplicated by the straight line path. The current flowing in the conductor like a beam by a beam charge and this duplicated by the magnetic field. This effect was discovered by the H.R. Hall in 1879 is called by Hall effect. Consider the electronic moving in the conductivity path within the magnetic field applied is the right angle to the plane with the add figure as shown in the figure in the working. Next continue by the working. The Hall effect sensor generally supplied as the integrated current within the necessary of single processing circuit. These are the two basic forms one such sensor. Linear where is output variables responsible linear with magnetic field density. These are the whole output show a sharp drop at the particular magnetic flux density. The linear output Hall effect sensor as shown by the figure. Working and explanation. Let's continue by the advantages. They are the highly reliable. Second one is after by the programming by the electrical angles of output offer high speed operation. They are the ability of the bit temperature range. Next continue by the disadvantages. They are required as a separate magnetic field operation. It should be mounted by does not affect these components. They are the open calorimeter output the about 20 megapascal or less. Next continue by the applications. One is piston sensing. One of the most common direction application is Hall effect sensor. It used by the binary switches of Poisson ratio Poisson sensing. Next by a DC current direct current transformer. Hall effect sensor utilization for the construction for the measurement of the direct current is current transformer. Next continue by the third one. Automotive fuel level indicator. Hall effect sensor is for the some output fuel. Automotive fuel is level indicator. The sensor is used for the difficult the question of floating element within the fuel tank. Next one is keyboard switches. Hall effect sensor switches are the computer keyboard is developed the 1916 by the Invert. Next continue by the animation of the Hall effect sensor.
How Hall effect sensors work? The Hall effect is the most common method of measuring magnetic field, and the Hall effect sensors are very popular and have many contemporary applications. For example, they can be found in vehicles as wheel speed sensors, as well as crankshaft or camshaft position sensors. Also, they are often used as switches, MEMS compasses, proximity sensors, and so on. Now we will go through some of these sensors and see how they work, but first let's explain what is the Hall effect. Here's the experiment that explains the Hall effect. If we have a thin conductive plate as illustrated and we set current to flow through it, the charge carriers would flow in a straight line from one to the other side of the plate. Now, if we bring some magnetic field near the plate, we would disturb the straight flow of the charge carriers due to a force called Lorentz force. In such a case, the electrons would deflect to one side of the plate and the positive poles to the other side of the plate. This means if we put a meter now between these two sides, we will get some voltage which can be measured. So, the effect of getting a measurable voltage, as we explained above, is called the Hall effect, after Edwin Hall, who discovered it in 1879. The basic Hall element of the Hall effect magnetic sensors mostly provides very small voltage of only few microvolts per Gauss, so therefore these devices are usually manufactured with built-in high-gain amplifiers. There are two types of Hall effect sensors, one providing analog and the other digital output. The analog sensor is composed of a voltage regulator, a Hall element and an amplifier. From the circuit schematic, we can see that the output of the sensor is analog and proportional to the Hall element output or the magnetic field strength. These type of sensors are suitable and used for measuring proximity because of their continuous linear output. On the other hand, the digital output sensor provides just two output states, either on or off. These type of sensors have an additional element, as illustrated in the circuit schematic. That's the Schmitt trigger, which provides hysteresis or two different threshold levels, so the output is either high or low. For more details how the Schmitt trigger works, you can check my particular tutorial for that. An example of this type of sensor is the Hall effect switch. They are often used as limit switches, for example in 3D printers and CNC machines, as well as for detection and positioning in industrial automation systems. Another contemporary applications of the Hall effect sensors are measuring wheel speed or RPM, as well as determining position of crankshaft or camshaft in engine systems. These sensors are composed of a Hall element and a permanent magnet, which are placed near a tooth disc attached on the rotating shaft. The gap between the sensor and the teeth of the disc is very small, so each time a tooth passes near the sensor, it changes the surrounding magnetic field, which will cause the output of the sensor to go either high or low. So, the output of the sensor is a square wave signal which can be easily used for calculating the RPM of the rotating shaft. Thanks for watching.
That is for Hall effect sensor is working and explanation. Thank you for everyone seeing my presentation. Thank you.